So the first assignment that y'all did was just solving linear equations, multi-step equations, which y'all been doing for years now. It's not something that's overly new. What we're doing today is kind of problem-solving strategies, word problems. Now, these are a little bit new. We don't really talk too much about them in Algebra 2 about word problems, but they're not too bad once you think about them and work through them. Because here are kind of 5 main steps. I put these up here because I do find these helpful in trying to solve these here. The first one's kind of read the problem carefully. Determine what the problem is asking for and assign variables to the unknown quantities, what we want to talk about, because we've done this with kind of area. Given a rectangle, the length is 2 times the width. Well, we can set the width as W, and the length is going to be 2W. We can set variables for these here. Make an appropriate figure or table if applicable. Let the given information and variables in the figure or table kind of make the representation. Draw it out. That's one of the biggest things, especially on the ACT. Draw it out. If they don't give you a figure to work with, draw it out. Now, there's some that drawing it does work, because if we're talking about 2 figures going certain distances, we can actually draw the distances out and see when they match up. Sometimes actually drawing it helps. Write an equation that represents the verbal model. The equation may be a known formula or one that you have to create that is unique to the problem. 4, solve this equation, and 5, interpret the solution and check that it is reasonable in the context of the problem. And really all 5 is saying is kind of how does it apply to the problem itself? Does it make sense for the problem? Because if we're talking about finding length and width given area or perimeter, the length and width can't be negative. That just doesn't make sense. Or when we plug it back in, that the amounts actually do add up, that they do work for the problem. And what they're really trying to tell us in this last step is to get rid of what we call extraneous solutions. An extraneous solution is a solution that works for the given problem, but not in the context that it's set. Now, we're going to look at some examples here. So talking about CDs and percent rate, one of the main ones that iconic ones, at least when I was growing up, that everybody used to reference was the train problem. 2 trains leave a station going towards each other or going away from each other. Find when they meet or when they intersect or where they're at the same distance. It's some that we also do. Now this first one here, we're talking about applications involving simple interest. Kevin invested a total of $8,000. He invested part of his money in 2 years, for 2 years in a stock fund that earns the equivalent of 6.5% interest. So 2 years, 6.5% interest. He put the remaining money in an 18-month certified certificate of deposit that earns 2.5% simple interest. If the total from both investments was $855, determine the total amount invested in each. So we kind of see what we're doing. We're trying to find out how much money he invested in either account or both. Now the first thing we can do is set up a table. Because we know that he set up one part that was how much? Our 6.5% interest was one of the accounts. He's also earning another account interest of 5%, and we can look at this as the kind of total amount. Now the tables don't have to stick to this exact format, but it's giving us a way to organize the data, organize our information. Now, how much did he invest total? $8,000, yes? So how much would we say he invested at 6.5? Well, we can just say that is X, because we don't know how much he invested in either one, yes? So we'll define one of them as X. Well, if we put X at 6.5, well, that's going to be X less of 8,000. So we can define the other one as 8,000 minus X. Because as one increases, the other is going to decrease. Now, we're going to kind of total these up. Well, 6.5 as a percent is, we can kind of put it above it, is 0.065. And 2.5 is 0.2 or 0.025. If we want to think of these as decimals. Now the time, because amount, might as well fill this in time. How much time was it for the 6.5% interest? 6.5 was what? 2 years, wasn't it? 2 years at 6.5 and 18 months for the 2.5. Well, we can't put it as 18 months because, again, we need the units to be the same. So we have to convert 18 months to years. So how many months are in a year? 12. So if we wanted to, we can say 18 divided by 12, which is 1.5. Now really, if we multiply this all together, we will get the amount that he would earn given X amount of dollars. So what we can think of this as being all multiplied together is 2 times X times 0.065. And we can do the same thing for our other one here. So we have 1.5 times 800 minus X, 8,000 minus X, not 800, times 0.025. Questions on any of this here? So we're really just using this to see what we have. And this here, both of these here kind of give us the overall interest, how much he would have earned after that given amount of time with the given amount of money set up. But what do we know about both of these here? Both of these will add up to be what? $855, yes? So we add them together and see when they will equal $855. Now, if it was asking us when they would be the same, given a certain amount, we would set them equal to each other. Because given on what it's asking is going to determine what we do. Now, at this point here, we just need to solve for X. So we're going to be multiplying these together. We're going to multiply them together to see what we get. Now, for the first one's a little bit nice, because 2 times X is just 2X times 0.065. Over here, we can do 1.5 times both of these here. Now we can say 1.5 times 8,000 is 12,000. Minus 1.5x. Now in the first one we still have the 0.065, and in the second one we still have the 0.025. Now here we're going to multiply 0.0625 by 2 times 2, which is 0.13. So 0.13x plus. Here we're going to multiply both of these by 0.025. So 12,000 times 0.025 is 300. Minus 1.5 times 0.025 is 0.0375. Now we can combine like terms. So in the calculator we can say 0.13 minus 0.0375, which gives us 0.90925. To get x by itself, we would subtract 300 from both sides, telling us that 0.0925 x is equal to 555. And last but not least, we're going to divide 555 by 0.0925, which will get x by itself. So 555 divided by 0.0925, which interestingly enough gives us a nice 6,000. Questions on this here? Because really once we got this set up, the rest of it was just going back to multi-step equations. Because the real big thing with any of these here is getting them set up, getting them started. Because once you get them set up, get them started, the rest of it kind of falls in place. Now that tells us, the 6,000 tells us what we have for what? The x, which is our 6.5% account. So realistically, if we put this back in, this here would be our $6,000. What would our 2.5% be? 200 or 2,000, because we know how much did he have total? 8,000. So those two should add together to be 8,000. Or we could have plugged it in 8,000 minus 6,000, which would give us 2,000. So the two amounts are just these here. Questions on any of this so far? So here, the other type that we have is involving mixtures. Mixtures is going to be very similar to what we just did. The process is the same, but we're looking at a different type of setup, not too much. Household bleach contains 6% sodium hypochlorite. How much household bleach should be combined with 70% or 70 liters of a weaker 1% hypochlorite solution to form a solution that is 2.5% sodium hypochlorite? So we know one of them is 1%. And we know the other is what? 6%, yes? So do we know the amount? Do we know the amount of 1%? 70. Do we know the amount of 6%? No. So we can call it X. Yes? But we know that the total needs to be what? Our 2.5%, yes? Now with this one here, unlike the last one, we're combining it, yes? Are we told what the combined volume is going to be? No. But I know however much of the 1% we put in, which is 70 already. We're adding to it the 6%, yes? So what are we doing? We're adding these two amounts together, so our total volume is whatever those two are. Now, in the previous one, it was set, because we were set at $8,000. Here, we're adding 6% to it. So however many liters of 6% we add will be added to the 70. So this is our total amount. Now, the overall concentration is really taking these two and multiplying them together. So 1%, which is our 0.01, times 70. So the total for our 6%, so 0.06 times x. And in our last one, we'll have 0.025% times x plus 70. Kind of our total for each. Questions on any of this here? Well, we know that the bottom two, that this one here and this one here should add together to give us what? This here, yes? So 0.01 times 70 plus our 0.06x should equal 0.025 times x plus 70. And we can multiply these together. 0.01 times 70, really just moving the decimal over to, is 0.7. So we have 0.7 plus 0.06x is equal to, so we can distribute this here. Well, we get 0.025x, or 0.025x, plus, pull the calculator up, 0.025 times 70 is 1.75. Now again, at this point here, we do need to get x by itself, and we need to get the other numbers on the other side. So we can use our order of operation steps. So here we can subtract 0.7 from both sides. And if we subtract 0.7 from both sides, we'll get 0.06x is equal to 0.025x plus 1.05. At this point here, we can subtract 0.025x, 0.025x from both sides. And if we subtract it from both sides, on one side we'll have 1.05. On the other, 0.06 minus 0.025. Yep, which gives us 0.035. And last but not least, we need 0.035x. Or we don't need the x, actually, just need the 0.035, because we do need to leave x by itself. 1.05 divided by, which gives us 30. So how many liters of the 6% do we need? 30. Because when we add a stronger solution to it, it should increase the overall percentage, yes? If we put 70 liters in, we should expect it to be, somewhere between half, like halfway between 1 and 6 is what we should expect. So 2.5, so we should be closer to 3.5 or so to get there. Questions on this here? As bad as you thought these were going to be? Most of these are all in the setup and how they work. So our answer is 30 liters. Any questions on any of this here? And I mean, we don't have to do it specifically this way, because it could have told us what the final amount was, and we need to see what combinations of 1 and 6% that we need to get there. Just like we did in the first one. We can set one of them as x, and the other is x minus the total amount, and solve from there. Questions on any of this here? Donna participated in a 40-mile biathlon that included running and bicycling. She spent 1 hour and 45 minutes on the bike and 45 minutes running. If her average speed on the bicycle is 12 miles faster than her average speed running, find her average speed running and her average speed riding. Okay. So we do have a bunch of information here, yes? But we do have two categories. We have running and biking, yes? Well, let's set up a table. Now this one here, unlike the last ones, we actually do have a formula for it. Because our formula when we talk about speed and distance and time is rate times time is equal to the distance traveled. If we know how fast we're going and the amount of time that we are traveling, we can find the overall distance. Well, we can denote one of these as running and the other as bicycling, yes? Now they gave us some times. One of them, she spent 1 hour and 45 minutes on the bike and 45 minutes running. Are those the same units? Well, one of them's dealing with hours and minutes, the other's dealing in minutes, yes? So we need to decide if we're going to convert it to hours or minutes. Which way are we going to go? It is very tempting to say minutes because minutes would be nicer, yes? What's speed in? Miles per hour. Because we always deal in MPH, miles per hour, yes? So if the speed's in miles per hour, hours, we have to have the time in hours. So for both of these here, we'll have to convert to hours. So really we're converting the 45 into hours. 45 divided by 60 is 0.75. So that means she spent 1.75 hours on the bike and 0.75 hours running. So our time for running is going to be 0.75. Her total time on the bike is 1.75. So we know the time. Do we know her rates? Her average speed on the bicycle is what? Miles faster than her average speed running. So we need to set one of them as x. So if we said her running was x, yes? Her biking would be what? X plus 12. Because it said in the problem, she bikes 12 miles an hour faster than she runs. So we have this here, yes? 41 miles is a part of this biathlon, yes? Do we know how much of that 41 is contributed to running or biking? Or is that contributed to both? Both, yes? So we know that whatever the distance she ran plus whatever the distance she biked should equal what? 41, yes? Well, what do we know from the formula? Rate times time equals what? Distance, yes? So let's do it. Rate times time, x times 0.75 is 0.75 x. And a lot of these problems here will end up having to multiply something together or divide. Because if they gave us the rate and distance, Well, we can put this off to the side. Time is equal to distance divided by the rate. We can manipulate it to get what we need. Now for the bottom one, we can multiply those two together. And here we can go on and multiply them. We don't have to wait to the problem. Because we can say 1.75x plus, so 12 times 1.75 is 21. And as we've already stated, if we add these together, 0.75x plus 1.75x plus 21 should equal 41. Now at this point here, we can combine like terms. 1.5, 1.75, and 0.75 is going to be 2.5x. Any questions on this so far? Now, one thing we can do for this here, I'm going to just show you this here so that you can see it. We could have done this on the previous problems. If you really don't like decimals of any kind, and we get some really ugly decimals, we can multiply by something we call a scalar. If I wanted to, in this case, I can multiply the whole thing by 10. Doesn't seem like it's a big deal, but if we multiply everything by 10, 10 times 2.5 is what? 10 times 21 is? You don't have to, but on some of the problems, this is taking it 2.5 plus 21 equals 41. That doesn't look as nice as 25x plus 210 equals 410. I can deal with 25 a little bit better. We're used to using 25s, dealing with 25s than we are 2.5. We'll get the same answer. It won't change. Because our next step is going to be to subtract, if we did it here, 210. The other way is to subtract 21. And in either case, here we're going to get 25x is equal to 200. Here we get 2.5x is equal to 20. Here I can divide by 25. 200 divided by 25 is 8. Really, how many quarters are in $2? 4 and $1, 8 and 2. Divide by 2.5, and we still get x is equal to 8. Because 2.5 plus 2.5 is 5. 20 divided by 5 is 4 times 2 is 8. Now 8 miles an hour is for what? Which of the two, biking or running? It is for running. Because running would be our 8 and the biking would be 20. And it does make sense that we can bike faster than we can run. Questions on this here? We good with this here? Solving an application involving work. I don't know why they put work in quotation marks. Quote unquote work. Yeah. Yeah. At a mail order company, Derek can process 100 orders in 4 hours. Miguel can process 100 orders in 3 hours. How long would it take to process 100 orders if they work together? So is the rate of time, so we have 4 hours and 3 hours, yes? Where do you think this number is going to be? Greater than 4, between 3 and 4, or less than 3 for them working together? It's very tempting. It's because most would probably say it's what? Between 4 and 3, yes? Well, if you're working together, it goes faster, yes? So it should be what? Less than 3. Because if one person can do it in 3 and someone else is helping them out, they're going to get it done faster than that. But we can think of this as total amounts, because 100 orders in 4 hours. So for them to process those 100 hours, we're really looking at 1 over 4, because it's one job. It's really tempting to use the 100 as part of the problem, but really for them to do one job, their main job is 100 orders, yes? So the overall part is 1/4. Well, erase that, because this is for Derek. For Miguel to do it, it's really, we're looking at 1/3. And our total, 1 over the time, would be 1 over x. Now, for some, we would say 1 over t for them to process this order. So if we add Derek's time of 1/4, so Derek can do 1/4 of the job per hour. Miguel can do 1/3 of the job per hour. Does that make sense? Put that there, because they're doing it as parts. And if we add those together to see how much time it would take them to do the job, we would set it up as this here. Now, we have fractions, yes? And with fractions, it's always good to get rid of the denominators. Now, one of the ways we can do this is finding the least common denominator, what number, the smallest number that will multiply across all of these to get the denominators to go away. But even getting bigger than that doesn't really hurt us here because we just have t by itself. But what's the first number we can turn 4 and 3 into? 12. Because 4, 8, 12. So one thing we can multiply everything by is 12. But we will also need t. Because we're going to multiply the whole thing by 12t to get the denominators 1 to go away, and get 2 to get this to be an easier problem to work. And when we do this here, well, the right-hand side's a little bit easier to work because the t and t will cancel out, leaving us with 12. Over here, 12 over 4 is 3. So we have 3t plus, because these cancel, leaving us with 3. 12 divided by 3 is 4. And this is not going to be 1, because 3t plus 4t is 7t. Divide both sides by 7, not t. I don't know where my brain went for a second there. Does 12 divide by 7 nicely? No. 12 sevenths. Or 1 and 5 sevenths. Or we can plug it into a calculator and let it do the conversion for us. Questions on this here? So the amount of time it takes them to do one order is 12 sevenths. Any questions on any of this here? Now we need to see how long it would take them to process 1,400 orders if they work together. So there's different ways we can go about it. One of them, we can go about solving it. Or how long does it take them to work or do a order of 100? So how many orders would make up the 1,400? 14. So what can we do? We can say 12/7 times 14. Which is, what's 14 divided by 7? 14 divided by 7 is? Times 12. So Jacob. 12/7 and 24 hours. Questions on this here? Now, just as a reference point. Nope, don't want that. The same done. Backing all. Yep, if I press too long, it wants to pull that out. There we go. Got it. Now, if we wanted to do this mathematically, the problem's still the same. Because we know what Derek can do. He can do part of the order in 1/4 hours, Miguel, and the time total, but we would change the total as 14 over t. Because Derek can do 100 orders in a fourth or kind of 4 hours, or do as 1/4 per hour. So we do the same thing, multiply by 12, we would get the same answer of 24. It would just be a different way to go about it. Questions on any of this here? This here is the last one that we'll look at, last type of word problem. In a jury pool, there are 8 more men than women. If the ratio of men to women is 8-7, determine the number of men and women in the pool. So men to women, we are given a ratio of what? 8-2. So this is men to women. And whenever we're given ratios, we're really going to look for proportionality. How are they going to be equal? And when we talk about proportionality, we're talking about 2 fractions being equal to each other. In a jury pool, there are 8 more men than women. So we can think of women as the variable x and men as what? Because if there are x number of women, the number of men is going to be x plus 8, 8 more than it. Now, which one's on top of the fraction or the ratio? Men or men? So on top of this fraction here would be x plus 8. On bottom, we would have x. Questions on this here? Now we need to get the fractions to go away, yes? One of the ways that you probably learned in middle school was multiply or cross multiply, kind of like the butterflies deal. That does work for this here. It does work with fractions. But really, we can use kind of a least common denominator, because we can multiply both sides by x, because here the x and x will cancel, yes? Are both fractions simplified? Well, no, the other one still has a 7, so I can also multiply both sides by 7, because now the 7 and 7 will cancel. This is the same process as cross multiplication. We just do it in 2 steps. Now the next thing we can do is multiply, so we'd have 8 times x, which is 8x, is equal to, here we'd multiply through by 7. 7 times x is going to be 7x, plus 8 times 7 is 56. And last but not least, we need 2 minus 7x from both sides, telling us x is equal to 56. And that's the number of women. So the number of men, we would need to add 8 to it and get 64. Do these numbers make sense that the number of men is greater than the number of women? Yep. And if we wanted to, we could say 64 over 56. 64 over 56. We get 8 to 7, which is the correct proportion. So that is our answer. All right, guys, so that is it